So, does everybody have coffee, something to drink, internet? Yeah, powerful laptops? Good. So with that, I think we can start. I would like to wish you a very warm welcome here in Berlin. I'm very glad to be here at API conference again. And this time we have a topic that is, that's important for me, for my everyday life. Let me quickly introduce myself so you know who is standing in front of you. And that's another important thing. If you want to be in contact with me, stay in contact with me, keep in touch, maybe ask questions or whatever, just remember this URL, stropek.me. At the right bottom corner, you will find a lot of links. Especially interesting for keeping in touch is LinkedIn, as you see here. GitHub, if you want to take a look at my samples and so on, and maybe this one. As you can see here, my video camera is running and I'm maintaining a quite active YouTube channel. I record nearly every speech and workshop I give, as long as it's not under NDA, and I put everything on YouTube for free. So if you want to dive into some topics, or if you want to rewatch some of the things that I tell you here, recap the samples, feel free to take a look at my YouTube channel. Sometimes the technology doesn't work. Maybe if I lose battery or run out of memory or something, but hopefully it will work. Okay? So stropek.me is where you can find me. What do I do? Well, I have a small company in Austria. I personally come from Austria, from a beautiful town named Linz. And in this company, we have been focusing on building software as a service solutions for more than 10 years now. Previously, I was the CEO of multiple consulting companies doing custom development for large, small, medium-sized companies, whatever. And 10 years ago, my partner and wife, Karin Huber, and I decided that we want to dive into this whole world of cloud computing, software as a service, and so on. So we sold our previous company, started a new one. Software Architects is the name of this company. And in this company, we build software as a service solutions for our own. So we market these solutions. We help other companies design and implement software as a service solutions. Our customers are partly very small startups who don't have the technical knowledge, but a great idea, and sometimes very large customers who have an established business, but who want to transition into the cloud, and we help them to move from a classical on-premise mode of software development into the cloud. This is what I generally do. Technically speaking, I'm a passionate developer. I love writing code. Every day where I can write code is a good day. I learned programming with C++ and things like that, and after that I switched to managed languages, especially C#. I did a lot of JavaScript development, but went a little bit away from JavaScript and entered the JavaScript world later again when TypeScript came out. So TypeScript is also a very important language for me on the server and on the client. And for the last year or so, I also fell in love, if you want, with a new language, that is Go. So today I do a lot of Go programming, and I'm looking forward to a talk that I will do tomorrow about building microservices with Go. But today, as announced in the workshop description, as you can see here, we will, when it comes to the live samples, live coding samples, we will focus on C# and .NET Core. However, if it happens that you don't use C# and .NET Core in your everyday work, don't worry. All the protocols, language features, and so on that we use today are open source, and most of them are available on different platforms too. So even if you are not a C# developer, you shouldn't immediately run out of the door if you are interested in things like gRPC, protobuf, SignalR, WebSockets, OData, maybe a little bit of GraphQL, things like that. If you're interested in those topics, I am sure that you can get something out of this workshop. However, as promised and as announced, my code samples will be .NET Core and C#. Everything runs on all platforms, Mac, Linux, and Windows. Every language feature, every platform I use is open source, available on GitHub. Every protocol that we talk about is open. We don't talk about any proprietary software. The only not free thing that I'm going to use is the IDE. I'm going to use partly Visual Studio, partly Visual Studio Code. So that's the only thing that is really something that you have to buy if you want to use it for commercial purposes. If you want to just learn, then Visual Studio is also free. Okay? So this is my personal background. Today we are going to focus mostly on the server, a little bit on the client when it comes to SignalR, but our main topic will be the server. Okay? Good. Now, for those of you who already were at a workshop, you know, from me, you know that I try to make workshops different from just sessions. If I give conference sessions, I have a very clear schedule and I have a clear time schedule. I exactly know what I want to bring across. I have carefully designed samples and slides where I really know what I want to do within 45, 60 or 30 minutes or so. Workshop means this should be interactive. This workshop is your workshop. I have a lot of material prepared, so even if you don't ask any questions, we will not be bored. However, I would definitely prefer if you ask questions. The workshop is as good as you ask and you do, okay? So, we take the time to discuss the matters. We can easily do some live coding if we want. As I said, I have some material prepared, but be prepared that we have to make it interactive, okay? Good. And because of that, I avoid slides in workshops. I don't like slides. I like talking, I like discussing, and I like writing code. This is what you can expect in the next, in this day, okay? And the first important discussion that I would like to do with you is about RESTful Web APIs, why and why not. I mean, I call this workshop Beyond REST, meaning that there has to be a world beyond the world of RESTful Web APIs, which are HTTP based and sending JSON across the wire, and probably you came to this workshop because you're interested. And my first question to you that I want to discuss is, why RESTful Web APIs? What is good and what is bad about RESTful Web APIs? This is the first discussion that I would like to have. And let me quickly introduce it before I open the discussion, okay? RESTful Web APIs based on HTTP and JSON are a great thing. They are all over the internet today. You can find them on every major cloud platform. Look at Google, look at Microsoft, look at Facebook, look at Twitter, look at many of the other cloud providers. HTTP-based REST APIs, and I know REST is an architectural pattern, not a strict protocol, but APIs based on the idea of the RESTful design pattern are really everywhere. So there has to be something about this that is useful. And you are here because we want to go beyond what's there, so there have to be some disadvantages too. So this is the question that I would like to discuss in the first minutes of this workshop. What ideas do you have? Why would you recommend in your team, let's build an HTTP-based REST API, or why would you say, no, it's not a good idea to build a RESTful Web API. We should do something else because. Who has ideas?
Super easy to consume.
Mm-hmm.
So really easy to request, really easy to get the data back.
You said it's super easy to consume. I agree. HTTP-based RESTful Web APIs are really super easy to consume because everybody implements HTTP. Everybody implements a JSON parser, and on nearly every platform you even have HTTPS and encryption support and so on. So we can say HTTP is really everywhere. Take a look at every programming language, every platform. You will always find some methods with which you can send HTTP and receive HTTP. That's definitely true. Thank you. What else? Yep.
I think more than the other. I mean, not so just because of not so much regarding HTTP, but if you're looking at other protocols, you sometimes have more about how to how to search, filter, and do other things. Whereas in HTTP, not HTTP, in REST, in pure REST, this is not really standardized. People can do a lot of different things there.
Okay.
And,
okay. So this would be a con, right?
Yeah.
Exactly. What if you need query capabilities? I agree. That would be a con. Query capabilities are typically things like filtering and sorting and paging and so on and so on. So let me quickly describe that, because I'm not sure that everybody understands what is meant with here. What you typically or often see when I do consulting at companies who start going into the cloud and who start using ASP.NET Core, maybe think of a fictitious company who has maybe some 100 developers, and they have been creating WinForms applications for the last 15 years. And this is very common, believe me. I visit a lot of companies like that. And now they transition to the cloud and they want to build web APIs. Now they read the hands-on labs and tutorials from, for instance, Microsoft, and they learn how to build APIs. They create an ASP.NET Core controller, they create an API, and they put the attribute HTTP post on top of it, and they receive some methods, and then they create a method which is called getCustomers, and maybe they also create something which is called getCustomerById, and that's it, and then they are happy and they have a RESTful Web API. Then the client developers come and say, okay, we need to display the list of customers in a grid. And this grid has to be configurable. The user has to be able to select the columns and has to click on a column header in order to sort the table. And the customer has to be able to group data. And I need to do some interesting paging, because I cannot load all the data at once. I have to load them package by package. And then the bad thing starts, because then the client developers go to the server developers and says, hey, please give me a web API, get customers by country. And by the way, we need one get customer by country ordered by name and one get customer by country ordered by, I don't know, company name. And then we need one paged and unpaged and the top 500. And if you don't manage that, if you don't plan that, you quickly end up with dozens or hundreds of methods and controllers which all implement a certain use case. They don't reflect the flexibility of the user interface that is required. Even if you don't have a configurable grid, believe me, I have seen endless number of applications where the front-end developers just want to display an autocomplete combo box with a customer name in it. And they are loading thousands of records with each hundreds of columns just to display the name and have the ID. Why? Well, the server developers didn't have time to create a specific web API delivering just the ID and the name. You get the idea? And that's a big problem. And if you just use REST as it is described in many beginner tutorials, then you will end up with a pretty weird design if you are thinking in that direction. You need something else, and this is where an interesting, let me insert a call out here, where an interesting standard comes in that we have on our agenda today. It's OData. OData has been designed and created to solve exactly that problem. And to make one thing very clear, OData is designed based on the RESTful principles. OData is REST. So strictly speaking, beyond REST is not perfectly right here. I would have to say beyond basic REST. Okay? OData goes one step further. But there is a second one which is not on our list today, simply because I had to make some decisions. I cannot do everything in a single day, but I would definitely like to mention it here. GraphQL. GraphQL is the more, let's say, the more cool kid on the block today. It has been created by Facebook, and GraphQL is not REST. GraphQL is definitely not based on the REST principles. So this could also be an option if you need some filtering, sorting, and so on. When we come to OData, I will tell you a little bit about the differences between GraphQL and OData. And I know a good friend of mine, Christian Schwentner, will do a talk here at this conference where he dives into details about GraphQL. So if you want to know, if you become interested in GraphQL after what I tell you in this workshop, visit the talk of Christian and you will get all the details there. Okay? Good. Thank you for this input. This is definitely a con. If we have basic REST APIs, that's a big problem. Yeah, and we need a solution for that. Good. What else? We have a lot of additional things. API versioning, is that a pro or a con?
It's a con because it's sometimes complicated to update the API, for example, for mobile clients.
API versioning is difficult. Yes, it is. The problem is that it is somewhat an inherent problem that you cannot really get rid of. I personally would put a pro up there which says the protocol is flexible. HTTP allows nearly everything. So if you have a RESTful Web API based on HTTP and JSON, and you need to add features, for instance, then the flexibility of RESTful Web APIs sometimes makes it easier to add features without breaking the API. If you have a very strict contract, for instance, like with gRPC, or also with OData, where you have a very strict schema, you are taking away a little bit of this flexibility. And here we have a two-sided sword. If you have a very strict schema where you say this is what a message looks like, then this is great because you can take a look at the schema and you know exactly what you have to send there. With the REST, that's not that strict. I can send any JSON and the server can do a bunch of ifs and then decide what to do. So yes, you are right. With any kind of web API, versioning of APIs is difficult. It is a thing. It is hard to do, and many companies forget about it. But RESTful Web APIs, they give you a little bit of flexibility. If we take a look at, as I said, gRPC, I will show you that gRPC uses protocol buffers, protofiles. They are much more strict, and you cannot just decide from one day to the other, oh, I will not send this field anymore, and the server will somehow have an if in the code and recognize that the field isn't there and do something meaningful. That's simply not possible with protocol buffers. With RESTful Web APIs, it is. You can do that. It's just JSON. Okay? But you're right. It's difficult, but it's a two-sided sword. What else? Any ideas? I'm sure you have ideas.
It's very obvious the learning curve is extremely shallow, so that's a problem.
The learning curve, is that a pro or a con?
It's a pro.
A pro, because it's very easy to learn.
Finding people who are able to do that.
Ah, I see. Now I know where you are coming from. Now I know where you're coming from. So, easy to learn, many people know it. Well, yes and no, definitely. The basics, everybody knows. Everybody understands the basics. When it comes to more complex scenarios, RESTful Web APIs aren't simple. Absolutely not. But I agree. I would say for RESTful Web APIs, you find tons of books, Stack Overflow articles, good blog articles, documentation on the platform that you have chosen, and things like that. YouTube videos, whatever you want to watch. So it is a very, very widespread platform. I agree. If you take a look at another thing that we have on our agenda today, SignalR. It's a great protocol. It's really great. It's super useful. It's also available on many platforms. However, the material is far less. It's good, good documentation, you have good courses online, but if you compare it to RESTful Web APIs, I mean, that's nothing. That's SignalR and that's HTTP, okay? Or HTTP REST. So I fully agree to that.
But it's hard to master for a whole company, and to governments it's very hard.
Absolutely. Why is it hard to master?
Because of the flexibility, and there's no contract about it.
I like that. I like that. So we need a con here. Missing contract. Well, there is something which is very important and something that we can use to solve this to a certain degree. That is called Swagger and Open API. I guess many of you are familiar with Swagger and Open API. It's far from perfect. I absolutely know that. But it is a good thing. Swagger and Open API, for those of you who are not that familiar with this platform, Swagger and Open API are standards to describe a RESTful Web API. You can define which URLs you have, which parameters you get, the types of the parameters. You can define you can define the data types similar to JSON schema, for instance. You can define HTTP headers. You can define status codes, and so on and so on. Especially OpenAPI version 3 has gone pretty far. OpenAPI version 3 is pretty powerful in describing REST APIs. And if you really if you consequently describe your REST APIs using Swagger files, Swagger version 3 files that you write carefully, or you add some code into your implementation that generates high quality Swagger files from your C# code, for instance, that's possible, then it solves the problem to a certain degree. It still leaves a lot of holes. So if you think about, for instance, OData, if you describe an OData REST API, then you can just say, and here we have a parameter which is called $filter, but then the rabbit hole starts. Because in this $filter parameter, you have a whole expression language similar to SQL to describe really complex things. So Swagger is a solution to a certain degree. You want to comment on that?
Yeah, I want to make a short comment to be easy to learn. From my experience, it's hard for object-oriented programmers to switch to RESTful architecture style. The thinking is different. So maybe it's easy to learn how to consume and produce an API. But going back, every object-oriented programmer are looking for a method or APC, or what a name, or what an argument you want.
I like that.
Something back. So the RESTful architecture style is very difficult to communicate, and you have to switch in your mind something to go what is a resource and not an entity or a class.
Exactly, I like that. The RESTful ideas sometimes simply don't map on a certain domain because we are really designing objects. We are designing collections and operations on them. So if you think of having a database where you want to do queries and inserts and updates and deletes, then the RESTful Web API really works well. But if you are, for instance, in the manufacturing business and you want to trigger more functionalities, you said in an RPC style, where you are more thinking in functions and less in objects, then sometimes the RESTful paradigm doesn't really work. Think of the cloud providers. I work a lot with Azure, with the cloud from Microsoft. And there is a RESTful Web API with which you can create virtual machines. Of course, you have a collection of virtual machines and you can post into this collection to create a virtual machine. It will take a few minutes and then, whoops, you have this virtual machine. Now you would like to reboot this virtual machine. What is rebooting? It is really an update on a status field where you say, is rebooting true? And then it should, no, that simply doesn't work. And what if we want to install a patch? Is it really a trigger, installing an operating system patch or something like this? Is this really an update statement? No, not really. So some things map really nicely on the RESTful paradigms and some things simply don't. And that's a problem. So for me, that's a con for RESTful Web APIs, but it somehow also is a pro because if you work in the area of databases, then RESTful Web APIs simply work great. because
Maybe you have to move on to the basic stuff. You have to add
Yep.
command query separation or something like this. It's not the basic stuff you bring us to the end.
Yep.
It's just a start.
Absolutely, absolutely. I fully agree to that. However, many people know it, they understand it, and if you take a look, for instance, if you look at the Office 365 Web API, you can send an email by inserting a row post to an HTTP REST API in your sent items outbox if you want. That sends an email. Does it make sense? Is that how you think of sending an email? But creating an appointment in your calendar feels more natural because your calendar is a collection of appointments. So why not inserting an appointment? You know what I mean? But if you want to invite somebody, then you have to create an appointment and add an invitation, and that somehow magically sends an email to somebody else. Again, it's crazy because you really would like to do a business transaction, invite somebody to a meeting, or reboot VM, RPC style. An RPC style design it's much more natural. But again, the orders table, you would like to create an order. Does it feel natural to define an RPC style create order, get order, update order, delete order when we are doing that on top of a protocol, HTTP, which understands insert, update, delete, and so on? So, both things are bad. What else? Yep.
Maybe performance.
Performance, pro or con? I would say con. Yeah. What's bad about performance with HTTP REST APIs?
For example, latency.
Latency, okay. Why? Do you have an idea?
I mean, it's HTTP.
Mm-hmm.
You share your latency with
Yeah.
the whole company network.
Okay. Okay.
Or the open internet, and if you want to have like near real time, for example, if you talk to SPS or via OpenCUA, then you get a better or a lower latency.
Lower latency. Yeah. I fully agree to you. To make one thing very clear, every kind of service communication will always be slower than just doing a function call. So please, I know this is not a microservice talk, please don't go so far to rip your software into so small pieces that every method call becomes a service call. Monoliths to a certain size are a good thing. Monoliths should never grow too large. But I have seen companies with 1.5 developers having 26 microservices and then complaining about performance. This doesn't make sense. It really doesn't make sense. I always have a quote, I've forgotten who said it, but it's so nice. Microservices turning a function call into an adventure. And that's really true. So just as a very important thing, not a single protocol that we talk about will ever be able to challenge a function call inside a process in C#, in C++, in Go, in Java, or whatever. That is simply not possible. However, HTTP-based REST works on the principle of request-response protocols. So we are sending a request, we get a response. And sometimes we use the same underlying TCP connection, sometimes not. Generally, the latency is not the best. If we take a look at other protocols like gRPC or SignalR, we have a standing TCP connection between the client and the server. We need to do less work when we want to send a message from the client to the server or from the server to the client. That reduces latency, but not only latency. The protocol, the payload, JSON, in RESTful Web APIs, it's pretty large. We can solve this problem to a certain degree by compressing the payload. Then we solve it to a certain degree, but it is like it is. JSON isn't very fast. So if we take a look at other protocols like gRPC and SignalR, and we will take a look at that, that's much faster, much slower, because they use binary protocols. Binary protocols like Google Protobuf, and we'll take a look at that. So performance is something that we need to improve if we have the necessity for this kind of application. But again, I would like to make it very clear. Don't try to overdo it. Don't try to over-design your APIs. Sometimes, think of a customer sends me an order. It really doesn't matter. It absolutely doesn't matter if it is the most performant way of sending this order because it happens, I don't know, 10 times a day. It doesn't matter. Processing the order will take minutes, hours, or sometimes days. So there is no need to optimize there. But if you think of a, like you said, of a production plant scenario where you have a lot of messages going back and forth, then you have to think about these things. And then you should really do an optimization on that level. Absolutely. So we have another con here that is solved to a certain degree with gRPC and SignalR, and we will take a look at that when we come to the hands-on labs. Yep.
I just want to say then the flip side of the performance optimizations of the other things, the pro is it's human readable.
Absolutely. I fully agree to that. I cannot count the number of times where I pressed in Chrome F12, go to the network tab, looked at the network traffic, take a look at the JSON and said, oh my God, it's absolutely clear what I did. This was my mistake. And this is super, super useful. Try to do that with gRPC. It will be pretty hard. It is possible, but you need to do a lot of things. SignalR, same is true. Well, via SignalR, via WebSockets, you can, again, send JSON, but then you don't have any advantages. I'm talking about binary protocols. I fully agree. Human readability is a very important thing. And I personally not only say human readability, also human writability. So it's possible to take a client like Postman or the REST client in Visual Studio Code or Insomnia or whatever client you use and just try it, just play with it, just learn it. Developer productivity is a very important thing. And I've seen many companies who forget about developer productivity and only think about efficiency in terms of performance. That's not a good thing. We have to balance performance and developer productivity. Because if it takes me 10 days to implement something, maybe it's more important to implement it in 2 days, even if it's not that fast. So that is a balance that we have. That is definitely a pro in terms of HTTP RESTful Web APIs. What else?
I found that caching can be both a pro and a con. So you've got fantastic support from HTTP for caching, but on the con side, it's really quite complicated
to do it right. Okay, cache header, no cache, because sometimes I absolutely agree. Things like e-tags, if match header, if not match header, not modified since, and so on. HTTP has a lot of power in it, and that is because of the nature of RESTful Web APIs. RESTful Web APIs use all these caching mechanisms to a good thing, to improve performance again. Other protocols like SignalR, they don't have something like this. So caching, yes, I agree. I would like to leave it on the pro side, but let's add a call out. Sometimes it's hard. It's similar to performance here on the left-hand side, human readability versus performance, it's the same thing. Yeah, and on the same lines of like caching, I would like to add one thing that is important here, easy to load balance. That is something that many people forget. HTTP is trivial to load balance on a server farm. You build a REST API, you put a reverse proxy load balancer and Nginx, something like your personal cloud offers out of the box in front of it, and it just works. I personally work a lot with Azure App Service. Azure App Service is a serverless or platform as a service to run web APIs and web apps. It comes with a load balancer built in. I just take a slider and I say, give me 10 nodes, press save, and within 10 seconds, I have 10 nodes running my web API, and the load balancer does all the heavy lifting. Done. I'm done. I don't need to think about anything here. It just works. Now let's think about how this would work with SignalR, for instance, with WebSockets. Way more complex, because we have a standing TCP/IP connection between a certain client and a certain server. And if we break this connection, we need to negotiate a reconnect. And for SignalR, for instance, this needs to be done by hand. You need to write code for that. And then bad things happen, because the nice thing with SignalR is that you have state. You can have state because you have a standing connection. You know that you have this client connected, and you know that the server can store some data about this client. And if you renegotiate a new connection, you have to somehow get this state again up and running. And if I get connected with my next connection to another server of this 10 of my web farm, well, this server might not know my state that I had previously. So sometimes the server farm in the backend, they need to talk to each other. They need to understand who is where. Also, if we take a look at very important things like duplex communication for gRPC and SignalR, that's great, duplex communication, but the problem is, again, we have a standing connection. If we have a load-balanced farm, and this server up here wants to talk to this client, maybe he doesn't have the connection to this client. This server down here has the connection to this client. So we need a kind of backplane, a kind of communication mechanism in the back end in order to communicate between the different servers that are behind our load balancer. With HTTP, we know that we have to design these things stateless, right? This is part of the idea. It's harder to load balance anything that keeps a connection up and alive. So that is much more work. And many people, as I said, forget about that. In simple scenarios where you have a single server and a bunch of clients, maybe a small to medium business app or casual game or whatever, it works perfectly fine. But as soon as you add multiple servers, it's getting hard. Additionally, because we have a standing connection between the server and the client, every single connection requires a certain amount of memory on the server. You cannot throw away all the data you know about the clients because you have an open TCP/IP connection. So how do we deal with tens of thousands, hundreds of thousands, millions of clients who are connected? Maybe they only send us data very infrequently, but still they have a connection. So we need a lot of memory. Get the idea? Therefore, to solve this problem, we need to scale out. But we just talked about it. Scaling out is hard. So load balancing, and I won't just say load balancing, it's also easy to scale. Scaling is much simpler with RESTful Web APIs. Clear? Question?
No, with another pro, and that's if you are following the RESTful paradigm, it's quite robust because it's idempotent typically.
Okay.
So you can repeat requests that went wrong before without bringing everything, just knocking up everything.
I like that. I like that thinking. Absolutely. Yeah. If you design your own API with gRPC, SignalR, or whatever, that doesn't absolutely need to be the case. You can model it like that, but I agree, the RESTful principles are really, they have it baked in. I fully agree. What about clients? Which client can consume an HTTP-based REST API? Every client. What about gRPC? Can any client consume gRPC? Nope. Absolutely not. gRPC is based on HTTP2, and for instance, the browser is not today, the browsers are not capable of consuming gRPC directly because they cannot control the HTTP2 messages to the degree that they need to in order to consume it. So, browser support. An HTTP REST API can be called from the browser. A gRPC service cannot. It's not possible. You need to have a kind of proxy, a translator in the middle that takes your HTTP request, HTTP 1.1 coming from the browser, translate it into a gRPC message and talk to a gRPC message on the back end. You can do that. There are ready-made services on the web, and I will give you links with which you can do that without a lot of programming. But still, you need to have an intermediary in the middle. With HTTP, that's not the case. Okay, so that is another pro here. I would like to add a con here that is maybe not obvious, but yeah, it somehow is. Code generation with Swagger, that's the stuff we had before, sometimes isn't good. Let's put it mildly, okay? If you generate code with Swagger, not all code generators for Swagger really produce high quality code. At least that is my experience. Some of these are outdated. You have 16 different generators for the same problem and they are not maintained very well, all of them. And it's really hard to decide with which generator you want to create your clients. We don't want to write clients by hand. That's simply not the case. I know REST doesn't have metadata, but I would say REST plus Swagger has. But the Swagger generators aren't that good. If you compare that to gRPC, for instance, that's a whole different story. The code that is generated there is of a much higher quality. At least it is today. It is not something that is baked into the principles we are talking here, but it is a restriction in the real world. Okay? I will show you some generators that you can use, and I will especially show you gRPC code generation. That is a con that I have experienced. What about, yeah, you have an idea?
Just because you mentioned the metadata, I mean, OData, of course, is one of the protocols which is then much stronger than a pure, simple REST.
Let's put that here. OData, you will see that today when we start coding, has its own metadata format. Unfortunately, it has a lot of flaws. And again, code generation with OData, it is simply broken. It is simply broken. It doesn't work. You need to have Visual Studio 2015, a 4-year-old Visual Studio. I mean, 4 years in IT. That's like Stone Age for historians. Nobody uses that stuff anymore. And the plugins, they are simply broken. It doesn't work anymore. And that's a pity. So yes, OData has metadata, but the thing that I said, code generation with Swagger and OData, is really a mess with OData. And I will show you that. OData has a lot of advantages, and I'm a big fan of OData, but OData has a lot of disadvantages too. And that's somehow the worst thing that you can have. A standard, a protocol, a library that is really, really useful, but its implementations in some areas is really bad. So you would like to use it, but you somehow don't really want to use it because it feels dirty and not completely up to date. But I will show it to you, and for some scenarios it is a rock star, and for some scenarios we should simply forget about it, and we will try to work it out. Good. What about broadcasting? With RESTful Web APIs, is it possible to somehow send something from the server to the client? Do we have a pro or a con here? Well, obviously a con. We can't. HTTP REST API, it is just request response. Server cannot talk to client. However, there is an idea that many people follow, and that is exception webhooks. Do you know what webhooks are? The idea of webhooks is simple. We just turn the RESTful Web API around. If the server wants to talk to the client, and the client is capable of receiving HTTP requests, for instance, another server, so we are talking microservice to microservice, we simply send an HTTP request back. And immediately, we have a duplex communication. The client, microservice 1, sends requests to the server, microservice 2, and the microservice 2 sends something back via webhook. Good, that's possible. But it isn't really part of REST. It doesn't feel natural. It is a trick. At the end of the day, it's a trick. However, so many developers are used to this trick. Take a look at Office 365, at Azure, at Google, at Facebook, at Twitter, at GitHub. All of them, they all support webhooks. So even platforms like Dropbox and things like, they all support webhooks. It's so common because everybody can speak HTTP. But at the end of the day, it's a con because it's not baked into the protocol. Now, what about the other tools that we would like to discuss in this workshop, gRPC and SignalR? Can the server send something to the client? Yes, it can. That's a big advantage of gRPC and SignalR. gRPC, yes, is a duplex communication. The server can send something to the client can something to the server, can send something to the server. We even support streaming. So we continuously send from the client to the server, and we continuously send from the server to the client, and that's at the same time. So we have duplex bidirectional streaming protocols here with SignalR and gRPC, and you will see that in our example that we will code today. So this is a big advantage for the other twos and a big drawback for HTTP. Let's go one step further. What about one-to-many communication? In a microservice environment, if you do event-driven computing, you often have the scenario that something happens here in this microservice and you need to inform a lot of other guys that this something has happened. Could be clients. Hey, alert the user, something is broken with this robot. Or could be another microservice. Hey, we just received an update of the customer's credit status, so be careful when processing orders, something like this. Is that possible with HTTP? Well, no. So we know one-to-many communication. OData doesn't bring anything to the table here, so we can forget about that. But what about gRPC? Is it possible to have a one-to-many communication with gRPC? No, it's not. But SignalR can. And now we are talking. Now we understand one of the big advantages of SignalR and WebSockets. In particular SignalR, not WebSockets. That was wrong what I said here. SignalR. The SignalR protocol supports broadcasting, and it has super powerful support for that. You can send to everybody except the one from whom you just got a message. You can create named groups of connections, send to named groups and all this stuff. So SignalR is really, really powerful when it comes to broadcasting. However, don't misunderstand SignalR. SignalR is not your broadcasting protocol for the super reliable microservices backend. SignalR is not a replacement for your message bus, message broker, messaging infrastructure. SignalR isn't an Azure service bus. SignalR isn't AMQP. SignalR isn't RabbitMQ or Kafka. That's definitely not SignalR. In SignalR, you have to be okay that you are maybe losing one message out of, I don't know, some thousands. It's okay. That's SignalR. It could happen. You don't want to do that when it comes to your precious orders from your customers or something like this. But still, SignalR is super powerful, and it is more a protocol thought for server to broadcasting to many clients. It's less a protocol for server to server, microservice to microservice communication. You can do that, but yeah, it's probably not your first choice. So an alternative would be here SignalR or some kind of messaging infrastructure. Again, in practice, things are not black and white, things are gray. Because if you take a look at Azure, for instance, I'm bringing examples from Azure not because Azure is the single most powerful cloud platform in the world. I'm simply bringing examples because I know Azure very well, and therefore I want to talk about the things that I'm used to and that I know. The other cloud vendors like Google and Amazon, they are also very powerful and they have their own features for that. But yeah, I can only talk about my own experience, and I have 10 years experience with Azure, so this is where I'm at home. Azure, for instance, has a service which is called Event Grid. And guess what? Event Grid is a professional messaging infrastructure. Super powerful, costs nearly nothing, and can send with a single instance up to 20,000 messages per second. So that is pretty fast, very efficient, very reliable. And what do you think? How do you talk to Event Grid? Via a RESTful Web API. Do you want to send a message? Well, you send the message via HTTP to Event Grid, and guess how Event Grid delivers the message to the recipient? Via HTTP. So Event Grid is a messaging infrastructure that speaks HTTP-based RESTful Web APIs. Well, RESTful, we can discuss about that, but HTTP and JSON-based Web API, but still does things like broadcasting It buffers messages. Imagine that the recipient is not there yet. It will keep the message alive for a configurable amount of time and send the message once the client comes up again. It, for instance, can do load leveling. If the producer sends a lot of messages, it floods the client, and the recipient cannot deal with the speed of the messages that come in. Understand what I mean? Event Grid can do the load leveling here. So in practice, yes, HTTP cannot do broadcasting and messaging, but if you combine it with intelligent server products, like for instance Event Grid, you get something nearly like that. And with that, HTTP-based communication becomes a viable option in the backend for message-based communication between microservices. A better option in the backend than SignalR. Okay? That's another con. The receiver has to be online. Again, if we are not talking about clients, but microservice to microservice communication, then it's super, super important that you design the communication between the microservices so that not everything explodes when one microservice is suddenly down for a few seconds. Maybe you have an update, maybe you have a problem, maybe there is a mistake, something like this. With HTTP, with gRPC, with SignalR, the receiver of the message that you send has to be online. There is no buffering in the middle. If you need something like that, forget all those protocols. You need a messaging infrastructure in the middle. You need something like Event Grid, Service Bus, RabbitMQ, or whatever you want to deploy in this area. Okay? We shouldn't forget about that. Okay, I like that one. Any additions? Anything that comes to your mind? Let's rephrase the question before we go into the first coding examples, okay? Imagine somebody asks you, I really like to do, by the way, I can give you this mind map if you would like to. I see that you take out your camera. I will check it into the GitHub repository where we'll give you the link, okay? And the software that I use here is called Xmind. You can download it for free. Okay. An exercise that I often do also for myself to become more clear about what I think about these technologies is the following exercise. I think of, imagine that you have an intern and you're having a coffee with this intern. It's a junior developer, not that experienced, and this intern asks you, hey Rainer, what is the sweet spot of a RESTful Web API? Where would you use it compared to the sweet spot of gRPC, compared to the sweet spot of SignalR, compared to the sweet spot of OData? What would you say? What would be the answer? Where would you primarily use what? What are role models for ideal situation where you should definitely go down this, that, or that road? Mm-hmm.
I would say public APIs, which I can monetize.
For which technology? Public APIs, a sweet spot for RESTful Web APIs. Okay, okay. Public APIs. Why do you say that?
Because as we have on the pro side, it's easy to use. Mm-hmm. Everybody knows it. Mm-hmm. So it's easy to sell.
It's easy to sell because everybody is able to consume it. I fully agree. I like what you say. I would just add one thing. Yes, if you add OpenAPI or Swagger, because then you can generate also client libraries, because I know a lot of developers who are afraid of directly accessing REST APIs. They want to have a client library in their language of choice C#, Java, Go, Python, whatever. And if you add Swagger to the equation, then you can add a Swagger file to your public API, generate the clients, put them on NuGet, NPM, wherever you want to give them, and then the clients really have a nice programming experience. So I fully agree to that.
Yeah, my thought was an API portal.
API, I agree.
Have, such functionality.
Absolutely. And another thing is that in practice, you will find on the market a lot of very powerful products doing so-called API management or API gateways. So these products, you can put them in front of your public API and they can do things like quota management. The customer is only allowed to do 100 calls per minute and then he has to wait for another few minutes. Or he buys a more advanced package where you let through 1,000 per minute or something like this. So you have a lot of really powerful products and they nearly cost nothing. They are commodity. You will get them nearly for free if you go to the public cloud, for instance. I mean, compared to other things. If you do that with other things, it becomes a little bit more problematic. I would never do a public API based on SignalR. I wouldn't do that. That's really unusual. I've never seen that before. Public API based on gRPC. Well, there is one company that is doing it a lot, and it's in the name. It's the G of gRPC. It's Google. So you get a lot of public APIs, especially those APIs which are not thought for consuming it directly from the browser, but which are more thought for consuming it from other servers. They do that based on gRPC. I mean, it's called Google RPC, and therefore they do it. Yep.
And stateless request response environments, it's perfect.
Okay. For requirements where this fits the stateless request response protocol, I absolutely agree. Maybe we talk about the other ones now. For me, I get the impression that you know where to use a RESTful Web API, but where is, for instance, the sweet spot for gRPC? Well, you maybe don't know gRPC yet, but guess.
Between microservices, between
Absolutely.
service to service.
Yeah. And this is where you should consider gRPC. This is really the sweet spot of gRPC. If you are in a microservices world and you need a super fast, super reliable communication between microservice A and microservice B, and because it's in the backend, you have a very reliable network. You don't have a network that breaks every now and then. It is not like your 4G network in the German railway, where I had to go with the German railway from Austria to here yesterday, and I tried to work in the train, and it wasn't that a good experience. I wouldn't use gRPC there. And yeah, also SignalR is maybe not the best protocol in this situation. So reliable network, communication between microservices. I fully agree. Yes. What about SignalR?
One question still for gRPC.
Yes, ask.
How is it if you don't want to have a very tight coupling between these microservices? You don't quite know regarding versioning, etc. Is that something where gRPC has downsides because of the binary protocol, and if you add another field or so, you have to change the consumers, or
you don't? I will tell you about that. In gRPC doesn't break if you just add a field. You can add a field, that's not a problem, but it has to have a default value. The server has, the recipient has to somehow do a meaningful thing if the sender didn't provide something. However, it is easy with gRPC to break something. You add a field without a meaningful default value. You just remove a field and reuse the field ID without having a reserved field, something like this, then really bad things are going to happen. It's easier to break. But if it breaks more obviously sometimes. In JSON, it's sometimes more subtle because, well, by now it was a string field, now it is a date field, but you send dates as strings. And then we all know how JavaScript handles numbers and strings, and yeah, with protobuf it's much more clearer. So things break more obviously, let's put it that way. Okay, what are the sweet spot of SignalR?
Real-time applications. Real-time applications.
Real-time applications? Isn't that with gRPC the thing, is it also real-time? Well, it somehow is. What do you mean with real-time?
Client application.
I agree, yes. Whenever you need a near real-time communication, and I'm not talking about hard real-time like in production plants, I'm talking about near real-time, meaning fast communication between an app, client app, and its server. Duplex communication, okay? That's the same here too, by the way. So if you have a client and a server and you need a duplex communication channel between these two, then SignalR is really, really good. So SignalR is a good communication protocol between your clients and the server. What about mobile apps? SignalR, good. I mean, think of, I don't know, you build an app and you want to inform the customer when his order has been processed. Would you use SignalR for that? No, why not? I agree, by the way.
Just because application can be offline.
Exactly, the application can be offline, it doesn't need to run. If you want to handle SignalR messages, you have to be kept in memory, and this is typically not the case for mobile apps. So for that, you would use push messaging. Okay? The SignalR thing, I would go one step further and say the sweet spot of SignalR is either a full client written, for instance, in Java or C#. Think of WPF. I mean, this thing isn't dead. It just re-rose from its ashes in .NET Core 3. So people are investing again in WPF and even WinForms. I see that on the market. Or if you have a browser client, a progressive web app, for instance. A web app where the user clicks on a button to generate a report and then the server needs to send some progress information to the client, things like that. There we really have a sweet spot in terms of SignalR. But for mobile apps, not so much. For microservice to microservice real-time communication, not so much. There we should consider gRPC. Now, what about OData and GraphQL? I said I will not cover GraphQL in more details, but we have to talk about it because it's important.
Query-heavy access to data, being able to filter a bunch of access to kind of rich.
I would put it that way. If you have a backend with query capabilities, and if you have a front end with needs for high level of flexibility in terms of displaying data. If these two things come together, well, I mean, take a look, it's kind of obvious. If you have a database in the backend, if you have a relational or non-relational database, no SQL in the backend, that thing has a lot of power in terms of queries. And if you do a very CRUD-oriented application, and many of us do, right? I mean, I know that everybody is trying to reinvent Facebook, but only a few of us do. Most of us write everyday CRUD applications, displaying data in grids, building forms, building workflows, and things like that. That is what many people do. And for that, OData is really, really good. I fully agree. Now, what about GraphQL? The same? Can I copy the stuff from there? It's called query language? No, I wouldn't say so. I would definitely not say so. The big difference between OData and GraphQL is that GraphQL is great if you have many, many microservices in the backend. So if you have a lot of microservices in the backend and you want to aggregate this data from multiple microservices into a single request that the client can send you, then GraphQL is really, really good. Think of displaying a product page on your web shop. You might have a title, many titles in different languages. You might have a description, many descriptions, short description, long description, different languages. You might have a price. Oh, finding out the correct price is really a difficult thing. Maybe you have some ratings from customers, stars. Where do we get them from? Maybe you have some images, different images for different products with different properties. Maybe you want to change the size or color and so on. You could imagine a really complex large system where each of this data comes from a different microservice. You have a product title and description microservice. You have a rating microservice. You have a pricing microservice. You have a product images microservice. You know what I mean? Now, if you want to have a client, let's say a web page where it displays such a product, you don't want to talk to each of these microservices because then you send 15, 20, 25 requests. Latency will kill you. And there, gRPC is really powerful. If you put gRPC in the middle, then gRPC can do the heavy lifting to gather this data from all parts. Sorry, gRPC, I meant GraphQL. I'm sorry, thank you for pointing that out. GraphQL is really powerful because it can do the heavy lifting about gathering the data from all these microservices and giving it back to the client with a single request. You can do that with OData too. You can do that with RESTful Web APIs, but GraphQL is particularly powerful in that area. You have a question?
No, I just wanted to say that OData, which is the expand feature, it is also, let's say, at least better than the pure REST.
Absolutely, absolutely. OData can do that, but implementing an OData service that is capable of querying intelligently multiple downstream microservices is a super interesting programming task, and I would love to participate in such projects because, yeah, it's a lot of code that you have to write. In GraphQL, it's really a piece of cake. That's the point. So, for GraphQL, I would say it's, let's call it BFF. It's the backend for front-end approach with many microservices in the backend. That is really the sweet spot. I'm not saying that you cannot use GraphQL for querying a relational database. You can do that, but it's not the sweet spot. Yeah, okay, so just the sweet spot. And last one, what about messaging infrastructures? Where is the sweet spot of messaging infrastructures compared to RESTful Web APIs, gRPC, SignalR, OData, GraphQL? Asynchronous. We have to clarify that. Async communication, I mean HTTP REST is also asynchronous. You are sending a request, then you wait a bunch of seconds, milliseconds, whatever, and then you get a response. So it's also on a micro level, it's also very asynchronous, but you are just waiting a bunch of seconds to get a response. It will probably not take hours or even days to get a response. If you have an async communication where the request is now and the response will be in minutes or hours or days, then messaging is really a good fit. I fully agree to that. What else?
Event-based applications. Event-based applications.
Event-based applications. Event-driven architectures. Event-driven architectures because we often have to broadcast data and we need a reliable system. I told you about the gray area with the event grid. Can you remember where you use HTTP as the protocol, but still you are talking to a messaging system? Yeah, I fully agree to that. Anything else?
Queuing.
Okay, queuing. Queuing for what?
Message queuing.
Yes,
So
for which reason?
To ensure transactions.
Okay.
For example. So you have to wait for acknowledgements.
Something like this. Okay, so kind of more complex message processing, like dead lettering if the recipient didn't receive. Yeah. Okay, yeah. Maybe I can say complex messaging patterns, e.g., dead lettering, something like this, where you want to have a more complex flow, duplicate detection, ensuring ordering of messages, things like that. Things like reprocessing of messages if the recipient dies during message processing and things like that. I fully agree to that. Okay, I am happy with that. Now we have a clearer picture. why we are talking about applications and protocols that go beyond REST, and we have a clearer picture where we can use what. RESTful Web APIs are still a very important thing, and just because I suggested a workshop beyond REST here does not mean that I say RESTful Web APIs are bad. Absolutely not. But they are not the only thing. And sometimes every problem seems like a problem where you need to have a hammer. And that's not the case. We need to choose the right thing for the right tool for the right job. Good. I will now save this, this result of our work, and then we will switch gears and start a little bit to look into the first technology, and that will be gRPC. I would like to go into gRPC, and I will show you how to develop a gRPC solution. We will take a look at the various aspects of gRPC, and from the hands-on aspects, I will show you C# and .NET Core. But let me quickly save this thing so it doesn't get lost. So, save as. So, let's put it in a folder where I can afterwards commit it to GitHub. So beyond, here is it, and let's put it here, and yes, that's this one, and also for those of you who don't have Xmind, I will export it as an HTML file. Yes, yes, good, and I will also put it here. Good. Yeah, I will check in those material later, and I will show you the GitHub repo in a bunch of minutes. Good. Nice. Good. Let's start. Take a deep breath, change of topics. Now we are less the broad area. Now we go a little bit deeper into gRPC. That's the topic that we will start now for the upcoming 15 minutes. Then we will have a break, and then we have 1.5 hours just dedicated to gRPC, okay? Good. So first, if you want to have the sample code that I'm going to show you, then please either take a picture of this here, or take a look at the video that I will put online, but you can also take a picture here. In that folder, you will find all the code, and if I do some live coding in the rest of the day, then I will definitely commit this code there. And here you will also find a folder, course material, where you find all the links, and I will add links that I will show you throughout this course, and you will get the mind map there, okay? If you didn't have the time to take a picture or just to write it down, come to me in the break. I can show you this link again. Good. I've put together a bunch of important stuff when it comes to gRPC in this markdown file. Let's first talk about gRPC a little bit. This is where gRPC lives, and it says it is a high-performance open-source universal RPC framework. RPC is all about remote procedure call. And the sister project of gRPC is protocol buffers. I know that gRPC can handle different encodings, so gRPC doesn't need to absolutely transport protobuf encodings, but in real life, protobuf is used in the overwhelming amount of cases. So in our case, in our workshop, we will talk about gRPC plus protobuf. Protobuf, protocol buffers, is also a project from Google. You'll find it here. And essentially, protobuf works like that. You write a so-called proto file where you specify message encodings. You see it here. You describe what is a person. A person has a name, an ID, and an email. The email is optional. The other two are required. Every field has a name, and every field has a number. And from there, you generate code. Code in Java, code in C#, code in many different other languages. You don't just generate the code for the server, you also generate the code for the client. So with that, you can immediately consume this service. You can implement the service and you can consume the service. That's the idea of protobuf. Protobuf is just about serialization of data. It's an alternative to JSON. You can use it, it's much, much more compact. So the whole idea of protobuf is to put as much information as possible into the least number of bits that you can do. That is what protobuf is all about. It's not about human readability. It's really about binary serialization. Protobuf has its value even outside of gRPC. You can use it in your own protocols. You can use it to archive data. You can use it to store data in files, for instance. You can use it with HTTP REST APIs. You can use gRPC instead of JSON if you want. Why not? It's just a serialization and deserialization protocol. And it happens that the support for protobuf in C# and .NET, the language that we have chosen for this workshop, is pretty good. It has been pretty good, and it's gotten even better in .NET Core 3. So gRPC uses this protocol buffer language to describe the messages that the sender sends and that the receiver receives, and it also describes the return, the responses. And gRPC additionally, let's quickly go to the quick start. So we will write some code here. So let's take a look at C# here. I am looking for, this is a protobuf definition, which is the kind of obligatory hello world sample. You see here we have a protobuf message which is the request. Here you have a protobuf message which is the reply, and this is how you define a gRPC service inside a protofile, and then you can use this with gRPC. You give it a name. You have a certain request message that the client sends to the server, and you have a reply message that the server will send to the client. And that's it. We have a lot of details to talk about, but that's the basic principle. You create a bunch of RPC calls, you create responses, you create requests, and that's it. Okay? That's gRPC. Then you take this file, you run through a compiler, it will spit out server code, it will spit out client code. The server code in C#, for instance, is an abstract base class where you just override a function and implement it there. Java, similar principle. Go, different principle because we don't have classes there, but that's not the topic today. So you add some implementation, and on the client side, you just use it. Okay? So you need to have a compiler. Do we need to have a compiler with RESTful Web APIs? No, of course not. For JSON, we don't need a compiler. This has to have a compiler. In C#, we have two different implementations. Maybe we can take a look at this one. We have one implementation which has been around for quite a while. It is essentially a wrapper around the C implementation. It's just a wrapper library. But with ASP.NET Core 3, gRPC is in .NET natively. It has really good support. So you can implement a gRPC service, an OData service, and a RESTful Web API in the same project, side by side, managed by the same router. And here the bad stuff comes in. It's not completely true what I just told you, because OData could do that, but it's not there yet. So OData is always a little bit behind. Why? Because they have a lack of developers, and only too few people take a look at the code and maintain it. So in the future, you will be able to do that, what I told you now. Today, OData doesn't have ASP.NET Core 3 support, so you can't do that. Theoretically, it would be possible. but you have to wait a bunch of months until OData supports ASP.NET Core 3. Currently, it only supports ASP.NET Core 2.2, but there, gRPC native is not supported. So, it isn't there yet. Conceptually, it should be there, but not today. I'm very sorry about that. So, today, I can say, and I will show you that, you can have a single project where you offer some HTTP REST APIs and some gRPC services in the same application with the same routing if you want. You can, of course, also do it in different projects. I don't care. But if you want to have it in the same project, sometimes this makes sense, why not? Okay? So this is important. We will only discuss the new ASP.NET Core 3 world. I will not discuss the old world. Okay, good. So, we want to see something before we go into the break. Absolutely no problem. I would like to show you a quick, the Hello World sample of gRPC, and after the break we will dive into that and add a lot of functionality, including bidirectional streaming and everything. So from now on you will see a lot of code. Let's create a new project. If you want to follow along, what do you need? Visual Studio 2019. If you would like to follow along but you don't have Visual Studio 2019, well, we will have a break in a few minutes. So if you say download Visual Studio Community 2019, Community is the free version. It's really free, as in not just 30 days. It's free for studying purposes. So for this training, it's really absolutely free, and it's also free for small companies or if you are a Microsoft partner and things like that. So if you just enter in Google, download Visual Studio 2019, here you have the Community Edition. And maybe if you want, you can use the time in the break to download it if you want. It's important once you have started the download, the system will install the so-called Visual Studio installer, which updates every day, I think. But luckily, it's pretty fast in updating, so let me quickly show you that. And the important thing that I would like to discuss is, if you want to follow along, you need to install the ASP.NET workload. So you have multiple workloads. Do you build desktop apps or web apps or web APIs? The thing that we are doing is ASP.NET Core Web Apps. This is what you have to check in order to follow along with my examples, okay? So while this is downloading, I will show you later on, we can stick to Visual Studio. And luckily, we should here have a project template which gives us a little bit of code to start with, gRPC service. It's just a project template. It does nothing magic. I will show you what it adds. It just adds a few lines of code, which makes it a little bit easier to get started. But we could create that from scratch. It's really, really simple. Let's add that one. And I will put it here in maybe a folder. Let's create that one. Let's say this is the API conf life. And I will put it in this folder. I select any empty folder and I will call it Beyond REST. And this one will be called Beyond REST Server, gRPC server. Good name? Okay, reasonable name. Let's do that. So, as you can see, gRPC service, nothing special. If you would like to run everything in Docker and do your debugging in Docker and so on, you can check that. I would not recommend it now because we don't need it, but it's really a nice feature. The important thing is that we are going to use ASP.NET Core 3. That's the brand new version. It's just up here, I think, less than a month. Good. Create. While this is creating, my installer has updated, and let me quickly show you what you have to install in the break if you want to follow along. Okay, project is ready. Modify. I always use the preview version, so I'm ahead of the release version. And this is what you need to check. See, this is the workload that we need in this course. Everything else is optional, just this one. Good. Now, let's take a look. This is our project. And here I can show you the first principle. This principle is the same for any language that you choose. So this is the so-called protofile. You see, the protofile is just in our project. It's nothing special. The only thing is this protofile is now, if I right-click on properties, it's now linked to the protobuf compiler. So Visual Studio, behind the scenes, takes this protofile and runs it through the Proto C# compiler. And this Proto C# compiler will create server-side and or client-side code that you can use to implement and consume this gRPC service. You see, here I can choose whether I would like to run it in the server, whether I would generate server code, client code, or both. You see? Good. For now, just create the server code. Here, you see, it's Proto version 3. I will only talk about the version 3. We have a little bit of name spacing, and here you see exactly the sample that you've seen before on the slide. But now it's real in Visual Studio. Now, if we compile this guy, I do that, build succeeded, then we will see that in the object debug net core that we have these two files, greet.cs and greet.gRPC.cs. Let's take a look at the greet.gRPC. And that's the same for all language. If you do the same in Java or Go, the concept is always the same. You take a protofile, you run through a compiler, and you get the language of your choice. And you see, it's compiler-generated code. We have the namespace, and here we have some classes. Let me quickly fold this class, this greeter class here. And this greeter class has some abstract methods. You see, oh sorry, another abstract class, the greeter base class, and here we should see the say hello method. And this say hello method is a virtual method which throws an RPC exception that it is not implemented. So we get a base class for the server from which we can derive, and then we implement the RPC calls that we need. Got it? This is what's happening from the services. This one. And if we take a look at the hello request stuff, well, if you take a look, here you have the reply, and here you have the request, and if I press F12, go to definition, then you will see that the system will automatically create a class for each request parameter and response parameter for each message type. And these message classes, they contain properties for each field that we define in the protofile. Get the idea? So the big difference between a RESTful Web API and this thing is that something like Swagger is really built into the system. It's not an optional add-on like with REST, it's where everything starts. And therefore the messaging is much stricter. You have to write a protofile. You have to generate code from there. With REST, you can if you want. Okay? So now let's quickly take a look at the service because we are nearly at break time. This is how trivially you can implement this stuff. Say hello is the method, gets a request, returns a reply, and you just new up the reply, access the field in the request, and that's it. It's really, really simple. That's all you need to do to implement a gRPC server. Now, before we go into the break, let me ask you a few things so I know a little bit better what I can expect as existing knowledge. Who would say he or she is a professional C# developer doing at least a decent amount of work in C#? Oh my God, that's okay. 3. Okay, with me it's 4. So okay, just to understand, Java, Python, Go, a little bit, but JavaScript, TypeScript. Okay, I see. So you all have background in object-oriented languages, right? Okay, I see. So you know what a class is, you know what an abstract class is. All these things are okay for you. Okay, I agree. So, because you are not that familiar with C# and .NET, I will talk about some language features in more details, and so you understand it, but I will not make it a C# course, okay? So we will not focus on all the different things, but still, I announced it, and I will use C# and .NET, but it's important that you just gave me this feedback, so I know that I cannot expect everybody to know C# in very details. And I will try to make sure that everybody can get something from this workshop. Again, because many of you are not C# developers, I don't expect you all having Visual Studio on your laptops. It's absolutely no problem to install it in the break, and it's absolutely no problem to remove it after this workshop, okay? So don't be afraid that Visual Studio will ruin your complete setup. That's not the case, okay? Visual Studio has been not the best uninstall, has not had the best uninstall experience in the past, but now a few versions ago they made it really, really nice, and this installer is really powerful. So if you want to follow along, even if you are not a C# developer, you will be able to follow along. Take the time in the break. Good. With that, we go into the break. We now have a coffee break for half an hour. At 11 a.m. we will continue, and the next 1.5 hours approximately will be dedicated to gRPC. We will build a more complex server, we will build clients, we will factor out the proto files into libraries which are reusable on the client side and the server side. We will do server-side streaming, we will do client-side streaming, we will do duplex streaming, all this stuff. So at the end of this 1.5 hours, I hope I will finish, otherwise we will go into the afternoon. That will be the first coding deep dive that we have in this workshop. If you have any questions during the break, don't hesitate to ask me. Otherwise, enjoy coffee, enjoy the snacks, and be back in approximately half an hour. Thank you.